Hello, Mikel.
Hello, can you hear me?
Now I can hear you. Okay, fantastic.
Oh, perfect.
So, Mikel is a specialist in laser technology with more than 50 years of experience in providing laser solutions for many different areas. Currently, he is managing director of Coherent Spain, which is a world-leading company in laser design and manufacturing for the industry, and I would say also in research, currently closer to me. So Mikel is going to talk about lasers for batteries manufacturing. And give me just 1 second, and I'll pass to you. Okay, Mikel, so now you should be able to show us your presentation. Right.
So can you see the presentation?
Yeah, we can. So.
Perfect. So thank you very much, first of all, to SECFO for inviting us to present the coherent solutions for battery production. The target of my presentation is to give you some introduction of what lasers can do to improve your production of battery cells or battery assemblies or packs. Yeah? And always under the point of view of materials processing. That means interaction of laser beams with materials. So first of all, if you allow me, I will make a short introduction of Coherent. So Coherent is a world-leading provider of photonic solutions. We offer a big portfolio of components, laser subsystems, laser machines, for a lot of applications in different markets. Yeah. The headquarters is located in Santa Clara, California. The company was founded in 1966. Actually, we are together more than 5,000 employees, and the company has 28 manufacturing sites in 10 countries. Also, you can see there some revenue numbers and figures. So as why is not okay. So the main markets we are acting is 4 markets. The biggest one is microelectronics. That means production of LED and OLED flat panel displays, as well as a lot of applications in the semiconductor industry. Materials processing, I will talk a little bit more in detail later on, but we have also developed and produced products, so photonic solutions for life science, components, instrumentation in life science, for example, medical applications like eye surgery or counting blood cells on blood streams. And the last market is scientific research and government programs. In materials processing, you know, when a laser beam interacts with a material, you can have different effects depending on the wavelength and the path length of the laser. So we manufacture and supply CO2 sources for material processing, as well as diaphragm solicited lasers and fibers, both pulse and CW, ultrafast lasers, diode lasers, excimer lasers, as well as tools for most of the material processing applications, as you can see over there. Since we are short of time, I will go directly into the topic. But first of all, I would like to invite you to let us know what are your applications, because we have a broad range of applications labs around the world. And basically, we like to share with the customers what is the application, and so we can discuss together what can be the part design, what material combination can be the best, or what is the right laser source for your application. So I would like everybody to contact us and try to work together in how to solve your production challenges with laser technology. So coming to the topic, in electric vehicles, we have a battery production, and I would like to separate the production in two parts. One is the production of battery cells assemblies, and the second one would be to pack those cells into a box, or depending on the requirements of the vehicle. So as I said, in battery cell production, we can have lots of applications, pre-treating the electrodes, coating, tailoring, connecting, joining, and on the battery packs, where we assemble those cells, we can have also many applications like cleaning, like marking, welding of the Busbars, to connect the cells themselves, or to weld the housings. I'm not going to go into many details, but I would like to choose some of the applications just to give you some color of what lasers can do in this market. So, for example, one of them is electrode structuring. So the idea is to generate microstructures in order to increase the surface area and therefore improve charging and discharge behavior of the battery. For this, we can use either excimer lasers or ultra-fast lasers. For example, with ultra-fast, we get almost no heat inputs on the electrode and no melting effects. And this is something which is valuable, to achieve the right result. Another example, for example, is to isolate negative and positive plates with usually kind of polymer-based material like polypropylene or polyethylene. Traditionally, this can be cut also with punch presses as well as knives. But we will get some tool wear and therefore some variable cut qualities. With the laser process, we go for scanner solutions where we can achieve really high speeds, above 1 meter per second cutting speeds. And for these materials, we use CO2 or carbon monoxide lasers. Also, for the future ceramic hybrid batteries, lasers can also play a role in cutting. This is another example. I chose this one because here we are welding two different materials, aluminium and stainless steel. This is a CID. CID is the current interrupting device. Basically, it's a safety device installed in batteries, which prevents the battery to get out. So as soon as the pressure inside the battery increases usually because of temperature, this device cuts the current to protect the battery. The 18650 cells are quite well known because I believe these are the ones used for the Tesla cars. Another example of a similar device, but in this case joining metals and plastics. So what you do is to create in the metal structure that helps to bond with the heat the plastic and the metal itself. This is for connecting welding terminals. Here we face also some challenges because materials like aluminum and copper has to be welded and welded in a way that the current later on is passing perfectly. And therefore you need to design an optical setup and to choose the right beam quality in order to be able to achieve a perfect result. This is another example of welding 3000 series aluminum for prismatic battery and against the cap welding. Usually aluminum welded by laser has a lot of challenges, mainly micro cracks. You have also hot cracking, pores, spatters. And as you could see here in the video, we can manage and modify the beam quality of the beam order to get really a very smooth, very stable, no spatter welding solution, and with no pores inside. Another application, cleaning of the housing, in order to eliminate any contamination coming maybe by electrolytes or any other debris created during the manufacturing process. The idea of cleaning is later on to paint a layer of protection, and this cleaning has to be not abrasive, has to keep the wall thickness, and really, as you can see in the picture below, the roughness almost is kept constant on the surface. This is another very demanding application at the moment, especially in Europe, which is the connection between different cells in order to get a more powerful battery. And here also materials are challenging, because we can have aluminum, we can have copper, we can have nickel-plated steels. Usually the solution includes also a scanner, 2D scanner with a high power fiber laser. As an example, I showed there with a 2 kilowatt laser, you can get 2 millimeter penetration in aluminum at 4 meters per minute welding speed. What it brings also to scanners is full flexibility in order to make the connection as robust as the application requires. And last but not least, another example is the marking directly in the product. Usually you need to trace each battery with a single unique code. Therefore, we go for data matrix codes, which are marked directly in the product, and this code stays there permanently, and the marking is very fast, fully flexible, and in this way you get the full traceability of the product and full readability later on. So I don't want to go too much into more details. Just as a summary, just to let you know, we have sources for many various different applications. So let us know what you are looking for, and then we can work together in order to optimize your process. So thank you very much for listening, and I'm ready to answer any questions you may have. Thank you.
Okay, thank you, Mikel. Thank you very much for your talk. It's interesting to see how many small parts of the batteries are being used or affected somehow by laser processing. I don't see any question around here. If you don't mind, as we are a bit tight of time, I might prefer to move on. But you can see, all of you can see here that you have Mikel contact. So if you have any doubts or you would like to see how coherent solutions could be incorporated to your added to your own portfolio of technologies for material processing, for batteries, or any other question you may have, feel free to contact him. So I thank you again, Mikel, very much for